today we're going to be looking at series and in general, and then specifically arithmetic series as well. So first of all, a series is a sum. So in our case, it's a sum of a sequence of numbers. And the summation notation that we're going to be using is your sigma notation, the capital S there, sigma. And it's going to be k is our index number. K equals 1 is usually where we're going to start with these, because you know how when we start with our term number, it's term number 1. So this is like the count. And then if we could go up to some n. And then the formula would go here. So, and then k would be 1, 2, 3, all the way up to n. Let's do an example so we can see how this looks. So here's example 14. We have this sequence 1, 4, 9, 16, 25, and we're going to write down an expression for s sub n. So we're going to start with our sigma notation. And first you want to look at well, you'll start with k equals 1 to n, because it goes on forever here. So the n will just keep going up to infinity. And you want to look at your sequence and figure out what the pattern is. So pretty clearly these are perfect squares. So the first one, if k is 1 and you did 1 squared, you would indeed get 1. And then 2 squared is 4. So it's simply k squared. Then down here you can test it. What I'm going to do is make a little table. I like doing these kind of tables here. 1, 2, 3, 4, 5, and then s sub k. Well, this should be k here. You have to be careful there. Okay. So what I'm going to do is I just want to test my formula, so I'm going to plug these numbers into the formula. So 1 squared is 1, 2 squared is 4, 3 squared 9, 4 squared 16, 5 squared 25. And then I look up here and it checks. I'm going to insert an example here. What if so it's the same example. We have a sequence 1, 1/2, 1/4, 1/8. And let's write sigma notation for s sub n. So s is the sum of n terms. So we start with our sigma notation. It's going to be k equals 1 to n, because it goes on forever. And then we have to figure out our pattern. And hopefully you notice that it's a geometric sequence, because if I multiply by 1/2, I'll get the next term. And so just remember your formula for a geometric sequence is the initial term, 1 in this case, times the ratio, which is 1/2, to the n minus 1. So that would be the formula for the summation, series. And then you could test it with let's test it here. Actually, it's Monday morning and I am a little slow. Whoops, see what I mean? I'm really slow. That's not what I want. I want the numbers 1, 2, 3 there. I'm just going to test a few of these. So if I plug 1 in here, I'm going to have 1/2 to the 0, which is 1. 1 times 1 is 1. Here, I'll just write what I'm doing. 1/2 to the 2 minus 1. So that's 1/2 to the 1, which is 1/2, times 1 is 1/2. And I'll do one more. 1/2 to the 3 minus 1. So that's 1/2 squared. That's 1/4. 1/4 times 1 is 1/4. And then you can look up here and check that it's working. What if you had, this is the next example, 42, 37, 32, 27. Okay, we're going to write the summation. K equals 1 to n. And it looks like these are going down by 5s. So that means it's arithmetic. So the arithmetic formula is to start with your initial value plus your difference times n minus 1. And then you could simplify that and write it a little more succinctly. Although I personally am fine with this. So that's going to be 42 plus 5 minus 5 that should be a K, really. I'm so used to using N there. And then you could check it. Okay, we'll head back to our other examples. So example 15. These I wasn't able to type into the Promethean, so I have to change colors. K equals 1 to 7 of K plus 1. So that just means start at 1 and go up through 7, and and it means sum. This sigma means to add them. So we're going to start with plugging 1 in, so 1 plus 1, plus, then plug 2 in, then plug 3 in, and 4, and 5, and 6, and 7. Just like that. And then add them all up, and when I did that, I'll save you the time of doing that, I got 35. Here's another one you can try on your own. So this one would be 1 over 2 to the 1 plus 1 over 2 squared plus 1 over 2 cubed plus 1 over 2 to the 4th plus 1 over 2 to the 5th. So 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32. And you can combine, I got a common denominator and add it all up. I'll save you the time of doing that. When I did that, I got 31/32s. There are some properties of sigma notation that are helpful. So if you are doing the sum of a sum, just like in calculus, you can break that apart, just like with derivatives and integrals. You can break that apart into two separate sums. One to A, so that notation stays the same. B sub K. I was going to say that's odd that these are A's. I think it's supposed to be N's. So like that was just a little strange. That's one property. And also this next one is similar to one we have in calculus as well, with a constant. So if you're doing the summation of a constant times something else there, some formula, you can pull that constant out front. It can help you with your calculations. Okay. Also, what happens if you sum a constant? That means you would just be doing C plus C plus C plus C an n number of times. So that would be C times n. Now we're on section F, the arithmetic sequence or series, and there's a formula for this, and the best way to remember it is to think about Gauss. Gauss, in my opinion, is one of the most brilliant mathematicians there ever was. He was also a physicist, and maybe even other things. Well, when he was young, I don't know quite how old, maybe 10 or something, he was in grade school in any case, and the teacher got frustrated with the kids because they were loud, and so the teacher had him sit down and sum the numbers from 1 to 100 to keep him busy. Well, it didn't take Gauss very long before he had the answer. And this is how he did it. So he reasoned 1 plus 2 plus 3 plus ... all the way up to plus 98 plus 99 plus 100. And he grouped the 1 and the 100 and added those and got 101. And then he did 2 plus 99, which is also 101. And then 3 plus 98 is also 101. And how many sets of these 101s would you have? Well, half of them, right? And there's a total of 100. So there's a total of 100, but you have to divide that by 2. So there's 50 sets of 101s. And so that's 50 times 101. In any case, you get the answer. But the pattern is what I'm most interested in. The 100 is the n. There are n numbers, so the 100's the n. I'm coming up with a general formula that will work for any arithmetic sequence. And then the 101 came from summing the first term and the last term. So a sub 1 plus a sub n. And that's the summation of a arithmetic series. If you ever forget it, you can, and you don't have a formula sheet, you can always think about Gauss and derive it on your own. Oh, I was looking too, the book uses u sub 1 and u sub n. Also, they gave an alternate formula. Here's the a sub 1, and then a sub n is any term in a arithmetic sequence, which is the first term plus the difference times n minus 1. So you can replace the a sub n with the formula for the arithmetic sequence. And then furthermore, if you wanted to, you could combine these. So you could write 2 a sub 1's plus d times n minus 1. Now we'll put this to use. So first, if you were confronted with this, you wouldn't necessarily know what type of sequence it is. So you would look at it and you'd notice that it is arithmetic. It's increasing by 3 each time, so the d is 3. And so we need to use the sum formula. N over 2 times, I'm going to use a sub 1. N is 50, because it tells us there's 50 terms. We know the first one is 4. And we need to find the last one. So you could use that alternate formula there, or you could just find it. So we know the last term is the first one plus d times n minus 1, which is 50 minus 1, because we're trying to find the 50th term. So this part right here will give me a sub 50. I could have written that there too. That's a sub 50, by the way. So I have 50 over 2. I'm going to have 8 plus 3 times 49, which is 150. Actually, I kind of prefer to distribute that. Easier to do in our head. 8 minus 3 is 5, plus, well, that's 150. Sorry. Let me do that again. 8 minus 3 is 5, 145. 150 minus 5. No, plus. See, I was, like I said, I need to wake up. Okay, that's 5. 155 times 50 divided by 2 is 25. So, let me see what I get. It's faster just to do this on the calculator rather than pull up the one from the board. So I get 3875 for the sum. This is our last example. I would recommend trying it on your own, and then I will do it as well. So we've got a difference of 7. Now on this one we have the first term and we have the last term, but we need to know the n, what this number is, because we need it in the n over 2. So I know this much of my formula, but I need to find n. So that means I'm going to need to use the arithmetic sequence formula that, let me think about this. So I'm trying to think of the fastest way to do it. But we know d and we know a sub 1. Oh yeah, cinch. So 141, we just plug it in. We have all the information we need. 141 equals the initial one plus the difference times n minus 1. Because we're trying to find n. Let's see, I'm going to add 6 across. 7n minus 7, add 7 across. 154 divided by 7 is 22. So my 22 is going to go over here. 22 divided by 2 is 11 times whatever that is. So I'll go to my calculator. Times 11. And I get 1485 for the sum. And that wraps it up.